Welcome to the last video in the series. The last video in Intro to Grasshopper Part 1, somehow you did it. There was a lot in this intro tutorial and so much of it must have been so frustrating. I love learning new things, but I always forget how painful it is, and I always forget that the most important part of that learning, the most valuable times, are those painful times where I hate it. But that frustration is so worth it. It's like a long, hard run. Anyway, thank you for making it this far. Now we get to actually see the pattern come to life. We get to add the crossbeams and see what the pattern looks like. It's hard to see the pattern when you just are seeing the points because there are so many duplicate points here. And we need them to be duplicates because, for example, if there's a line from here to here, there's also a line from here to here, and these lines connect, and so there are 2 points there, one for even and one for odd. But let's make those lines and see this pattern. We can do that by getting a list item component first, and we'll get 4 different line components. And we want the line AB, this one here. Let's copy it, and let's copy these 2. So now we have 4 of them. And I got 4 of them because there are going to be 4 lines in each of these patterns. If we go back here, we can see the four cross braces on each. We have 1, 2, 3, 4. And even on the zeros, the ones that are open, we have 1, 2, 3, 4. 4 lines. So let's go back over here, and we're going to do the same thing down here. Actually, we don't need to copy this yet, because this is we're going to use this in a little bit different way. In the past, we've been just using this to grab one item or a specific item, depending on which index we choose. But we want to choose all of them, but we just want to separate the list. And so we can go down here and click this little plus. And since there are 8 points in each, we want to go up to +7. This is 0, 0 plus 1, 2, all the way to 7. And now we can choose each point individually because each point individually is coming out of each of these 8 different outputs. So we'll just experiment a little bit here. We'll put point 0 from each of these squares into the A, and then let's see which point needs to be point 1. Okay, it's not that one, not that one. That one looks good. And if we choose this one, then this will be our 1 in the pattern. This will make all of the even squares the closed squares. So these will be the squares that have the full cross brace, and the odd squares will be the open ones. So let's keep experimenting until we find the next line. That's a good one. And we'll go down to see which connects to index 2. That's a good one. Now I'm going to skip to 4 here. Okay, that's the last one. So now we have all 4 for the closed squares. And let's do the same thing for the open squares. I'm going to copy this by pressing Alt and dragging this down. We'll plug the odd branches in here and experiment again. That's a good one. That's a good one. That's a good one. And that's our last one. So now that we have all the correct lines, let's merge them all into one component so we keep them together. Merge. Okay, and now we can hide all of these. And let's organize this a little bit. I'll group this and call this closed pattern. And these will be open pattern. So let's make sure we don't have any hidden lines in here, any extras that are not supposed to be there. Let's first look and see what's actually coming out of this. So this, if we hover over, we can see that the bottom one is branch 51. So we have 52 branches here, and each branch has 4 lines in it. And that makes sense. Let's get a tree branch component and a number slider between 0 and, let's actually go higher than 51. Let's go to 80. And we can see that that's the first branch. It has 4 lines in it. And this all looks good so far. But what happens when we get to the end? So that's branch 12. So that's the 13th square. And then if we go to the 14th square or branch number 13, it pops right back over here, which is exactly what we want. And it's working because these polylines, these squares that we started with, are coming from this filter, this stream filter, and we already called the crossovers. If you can remember what we did back here, we called all the crossovers, and since it's not wrapping, wrap boolean is 0, we're picking this stream, and we called all the crossovers. But if we go back up here and plug in, say, the circle surface, we didn't call the crossovers, and we didn't do that so that this part down here would be easier, and we could just do odds and evens like this, and the pattern works out well. But because we haven't called the crossovers yet, there will be some extra lines, extra branches that we don't want. And so let's go back to 0. And so this is our first branch with 4 lines. And let's go all the way up till we get back to 11. So it looks like there are 12 squares across the bottom. And then if we go to number 12, we have this. There are actually 4 lines here that are all vertical and laying on top of each other. So we don't want those. We want to call all the branches every time we go around the circle once. So let's go back over to the beginning and see what we grabbed. We have this component here called indices to keep, and we pulled this out of this component that we made. And so this gives us a number of all the indices that we want to keep, the ones that won't be called. And so this is where this comes in handy. These are going to be our branch numbers for all the good branches, and it skips over the numbers that every time we go around this circle once and hop up, it skips over that branch. And so we're going to use these numbers. If you can see, it goes from 0 to 11, and then it skips branch 12, or indices 12, because in this case we just had a list, but now we have branches. And so it goes from 11 right to 13. And so we have a ready-made list of numbers here that will tell us which branches are good and which ones we need to skip. So I'm going to copy this component, this list of numbers. I'll delete that for now, and let's bring this over here. And the first thing we need to do is get a number of branches here. We need a number that tells us how many branches are in this entire tree. So I'm going to close this, or delete that. And to do this, let's get a list length component. And this is just kind of a workaround. I don't think there's actually a component that just tells you how many branches are in a tree. But if we get a list length component and we flatten this list, then this is going to give us 39 different values. They're all 4. We know that there are 4 items in each one of these lists. But the important part is there are 39 different values in this list. And so let's get a list length again. And so whatever's coming out of this second list length component is going to be the number of our branches. And so if we hover over this, we can see that the last branch is branch 38, and because we started at branch 0, we know there are 39 branches. So these two combined will tell us how many branches are actually in this tree. And then let's get a smaller than component. Whoops, smaller than. And kind of similar to what we did with the odd branches when we wanted to make sure we weren't trying to grab any branches that didn't exist in the tree. We're going to do that here and make sure there aren't any indices here that aren't in this tree that we're about to call. And so this number going in is 39. So if there are any indices in this that are greater than 39, we're going to remove those indices. So I'm going to get call pattern again, and these should all be true unless for some reason we had more indices in this indices to keep list than we have actual branches. And so now this is a refined list that ensures that all the branches we're about to grab are actually existing branches. So let's get a branch component again, and these will be our branch numbers, and this will be our tree. And so just by doing that, now we've called all the extra lines. We can delete this, and we do want to do this if it's a wrapped surface, but we don't want to do it if it's not a wrapped surface. So we're going to need our wrap boolean again and another stream gate or stream filter. So stream filter, And I'm going to go back to the front and grab this wrap component, copy it, and we'll bring it over here. This is going to be our gate number. And so this is going to be 1 if it's wrapped and 0 if it's not wrapped. And so it says true, which is equal to 1. We plug that into the gate. And so if it is wrapped, in this case, we do want to grab these culled lines. And so those are going to go into stream 1. If it's not wrapped, then this will say false, and this gate number will be 0. And we just want to use whatever is coming out of this component instead. And then I'll get a curve component, plug that in, and we can flatten this list since this is everything we need. These are all of our cross braces, called if they needed to be, and so we only have exactly the number of lines that we need, and we can get a nice component called join curves. And so what this does is every time a curve's endpoint is landing on another curve's start point or endpoint, it will join those curves. And so let's get 2 list length components here to show this. And let's get 2 panels. So there are 144 curves in here, and there are only 24 curves in here because it combined all the curves. So let's get a list item, and we can see that this now is one long polyline curve. Okay, good. Let's delete these, delete that. Okay, our cross braces are ready to go, but now we need to do something with the squares because we don't actually want them to be squares. We want them to be individual lines and lines connected. So we want like this line connected to this line, connected to this line. So we have all the verticals and all the horizontals separated. So first, let's clean this up a bit. I'm going to hide all of those points, and we don't need to see anything until we get to the join curve. I'm going to hide all of those lines, and all of our cross braces are in here. We still have our polyline squares showing, but we're going to explode these and separate them into horizontal and vertical lines. And we're actually not going to start with this set of lines, so I'm going to hide this. We're going to start with the culled crossovers. So we used this list of squares to make the pattern of cross braces, but we'll use this list of squares here because these are already culled regardless whether or not it's wrapped or not. And we don't need to make a pattern out of these, we just need the lines. So the first thing I'll do is copy this and plug that in there. And for now, I guess I can keep the wire as default so I can see where this is going. And I'm just going to pull it way down here. And I'm going to hide this, all of those, and go back up here. I don't think anything's showing from here. It's not. I'm going to hide all of these. So these should be the only square lines showing. I'm going to hide it just to make sure. And the first thing we can do is get the explode component. So type explode and plug those in. And so now instead of 36 different squares, we have 144 separate line segments. So 36 times 4 is 144. And we can see these branches are pretty messy. We have each branch curly bracket 0, 0, 0, 0, 0, 0, 0. We definitely don't need all of those zeros, so I'm going to right click here and just click simplify, and now we can see that all the branches are just 0, 1, 2, 3, and so on. A much simpler way to identify the branches. And each branch has 4 items, the 4 segments that were making up the square. Let's get a list item component, and let's do the same thing we did over here. To get each individual point, we're going to get each individual line. So I'm going to click this plus until we have 4 different outputs, and each of these 4 outputs is each line segment coming out. So that we can see these individually, I'm going to get a curve component and copy this 4 times, or so that we have 4 of them. I'm going to hide all of these for now and plug each of these in so we can see that these are all horizontals, these are all verticals, these are all horizontals, and these are all verticals. So let's separate the horizontals and the verticals into 2 separate merge components. So this is horizontal and this is horizontal, so let's put these together, and we don't need that. And these 2 are verticals, so let's put these together and get rid of D3. Now we don't need these in branches anymore. It would be better if they were just in one list. And so now in this component, we have 35 different branches, each with 2 lines. But let's just make this one long list by right-clicking on the output and going to flatten for each of these. Now we have 72 lines in this component and 72 lines in this component. But a lot of these lines are duplicates because a lot of these squares, of course, overlap with each other. So there's another nice component called remove duplicate lines. Just type in remove, yeah, here it is, remove duplicate lines. And this will get rid of all of those overlapping lines. So in this, the output is 72 lines. In this one, the output is 36. And so we've gotten rid of half the lines there. Let's clean this a little bit. And just like we did up here when we joined all the curves to make longer polyline curves, we'll do that here. Get the join curve component, join curves. And so now we've joined all the horizontal lines there. And I'm going to press Alt and join all the vertical lines there. And so we went from 36 lines to 12 lines. And from up here, we went from 48 lines down to just 4 lines. 1, 2, 3, 4. So we can hide all of these now. And let's get an entwine component. And so this is going to put them in separate branches. It's not necessary really to have them in separate branches, but just in case we want to grab verticals and separate verticals from horizontals later, we can put them in separate branches. So all the vertical lines are on one branch, all the horizontal lines are on another branch, and I'm going to simplify this again. Now we just have branch 0 and branch 1. Branch 0 is all of the horizontal lines, and branch 1 is all of the vertical lines. And now we can add thickness to all of these lines. We can go back to our article that we've been referencing, and up to this equation. In this first part of the sentence, we can see that all the horizontal and vertical elements, so these are all of what we were calling squares, but now we have just horizontal and vertical lines. All of these have a thickness of t equals 0.1 L. And all of the diagonal cross braces have a thickness of t equals 0.05 L. And so the first thing that we need to do is get L. So let's get a list item component. And what we're doing here is just grabbing one of the segments from these squares. I'm going to flatten this list. And so what's coming out of here is just one line. It doesn't matter which one because these are all the same length, and we need to figure out what is the length of that line. So let's get a length component. It's this one here, and you can see that the input is C, and that's curve. Let's put a curve into that input, and it's going to give us the length of that curve. So now we have L, and we need to multiply L by 0.1 for the vertical and the horizontal lines. So let's get a panel and type 0.1 and get a multiplication. So multiply this length, this is L, times 0.1. So this is going to give us our diameter for all of the horizontal pieces. And let's do the same thing for all of the cross braces, but instead of 0.1, let's go back to the article. It says 0.05. So we don't want this to be 0.1, we want 0.05. Okay, so this is the diameter for all of our cross braces. Okay, so we're almost there. Now we just need to give these lines these thicknesses. So essentially what we want to do is make pipes out of the lines, and there is a pipe component in Grasshopper, but the basic pipe component runs pretty slowly compared to the parameter mesh pipe component, because the mesh pipe component is, as the name suggests, making a mesh. So I'm going to type parameter pipe mesh, and it's these top 4 inputs that we're interested in: the radius, the curves, which are these lines, and the U and the V. So first, let's duplicate this, because we have 2 different sizes of pipes that we need. This one we'll put in here. I'm going to actually hide these for now. And these are our cross braces. We'll put these in here. So our horizontal and vertical ones are going to be the thicker pipes. Let's get a division. just type backslash, and because this is diameter, we need to divide this by 2, so dash dash 2. And now we have a radius. We'll plug the radius in there and do the same thing for this diameter. And now if we preview this back on, we've got pipes with the appropriate thickness. But you can see that these pipes aren't very clean. They look a little too abstract. And that has to do with our U and V inputs here. If I hover over this, you can see that there are 11 locally defined values. That's describing how many divisions are in each curve. So if this is one curve, this one that's going around the top, that curve has been divided into 11 different segments, and there are just straight lines going from point to make up those segments. And so that's why we have some of these longer straight lines. And so if we increase the number of divisions in this U input, and also increase the number of divisions in this V input, because right now, if I hover over the V, we can see that there are 5 locally defined values. That means that going around the circle, around this pipe, instead of an actual circle, so imagine a circle has been divided into 4 points, and the endpoints are those 5 V values. 0 and 1 are the same point because the circle meets itself, and then 0.25, 0.5, and 0.75. The circle's been divided, and then those segments make this square. And so instead of a circular pipe, we have something that looks like a square. So we just need to increase the U and V value divisions here. And to do that, let's just get a range component. And we don't need to change this top input. The default is from 0 to 1, and that's exactly what we want. If I hover over this, you can see I have 11 parameters going from 0 to 1, and so this is just divided 1 into 10 different pieces, 0.1, 0.2, and so on, all the way to 1. And range is going to do the exact same thing. So if I hover over this, you can see that what's coming out of the output is exactly what's going into the U already. So from 0 to 1, it's divided it into 10. The default input for N is 10. And that means that it's just divided 1 by 10 and giving you every step of the way between 0 and 1 to 10. And so all we need to do is just plug a bigger number into N, and we'll get more steps between 0 and 1. So I'm going to start at 10 and go to, let's say, 60. I'll plug that into the N, and let's put that into V. Oh wait, that's supposed to go into U. So I'm going to right click and say disconnect and then put it into U. And we can do it on both of these. And the parameter mesh pipe component can be a little finicky. So you just have to keep adjusting it until it actually works. But if we increase this number, you can see that this is getting a little bit closer to matching how we would like it to look. And 60 is okay for this. For different surfaces, maybe we want a different number, but that works for now. And let's do the same thing for the V input. I'm going to get a range component again. And we probably don't need to go quite as high as 60. Remember, we're starting at 4, 0.25, 0.5, 0.75, and 1. So let's go from 4 to maybe 20. And I'll put that into the divisions input, and let's plug this into both of our V's. And then if we increase this, keep an eye on this square pipe here, it should be getting more and more circular. So 15 seems to work. That looks enough like a circle. And that's pretty much it. You did it. That's basically all there is to it. There's just a couple more things I'll just go over to wrap things up in case you're interested. So I recorded this in Rhino 6, and that's because when I started recording it, that's what I had. You're probably using at least Rhino 7, and everything that we went over is exactly the same in Rhino 7. And just to make sure that that's true, I'm going to open this up in Rhino 7. So I'm going to save this, and save this. Okay, so here's Rhino 7. Let me open up Grasshopper. And here's our file. I'll zoom in on the perspective. So everything's the exact same in Rhino 7. There's not a lot of differences in the Grasshopper versions between Rhino 6 and Rhino 7. There are some differences. So as I'm recording this part of the tutorial, Rhino 8 is not out, but the work in progress version is out, and I imagine Rhino 8 will be out sometime, this is just a prediction, maybe in the spring of 2023. And hopefully by then I have some tutorials for Grasshopper 2.0, which will be quite different than this Grasshopper version. But for now, let's just finish up this tutorial with Rhino 7. And I guess the only other thing to really do is to preview these in a different way. For one thing, the mesh edges aren't really doing much for us. So I'm going to go to Display and down to Preview Mesh Edges, or you can also just type Control-M to turn those off. And we have some strange things going on here. I don't know what's happening exactly. So again, the parameter mesh pipe, even in Rhino 7, like I said, it's a little bit finicky. So just adjust these U and V inputs if it's looking strange. But that I just adjusted this down to 55 and it fixed it. And so let's get some different colors for everything. Let's get a BREP component here, and I'm just going to scroll. I'm going to drag it back up here just for a moment so that we can unpreview all of these, and let's actually get a merge component and a list item component. Let's merge all of these surfaces into this. We'll put it in here, flatten. And then I'll get a number slider between 0, 1, 2, 3, and 4. So 0 is less than 4 because we have 5 different surfaces. And then we'll use that to pick our input BREP. So there's our circle again. I'm going to set the wire display to hidden, and let's bring this back to the end so we can adjust all the colors together. So what I'm going to do is type custom preview, or start typing that until I can just grab this component, and then create material. Let's get a create material component, color swatch. And there are 3 different inputs for color that you can kind of play with. So I'll just make 3 different swatches. And these other 2, I'm not sure that they'll really make much of a difference, but we can see the top one probably will in this case. And then this T input is transparency, and that takes a number between 0 and 1, so 0 less than 1.000. 0 is completely opaque, and 1 is completely see-through. And then this is the shininess, basically. Shine. 0 is no shine, 100 is max shine, so 0 less than 100. And these go into our material input. And then let's copy everything we just made for the materials. Bring it over here, and let's copy it twice more so that we have 3, because we have 3 different kinds of objects here. We'll hide all of these. Let's just hide everything else. And I'm actually going to turn off the grid. I'm going to type grid, enter, H, enter, O, enter to get rid of everything. And then this can be our BREP geometry, this can be our horizontal and verticals, and this can be our cross braces. So let's make this pretty transparent with that shine. And the thing about BREPs is it's going to, even when you have the custom preview, it will, okay, if we put this to white, you can't really see the lines anymore, but they are still kind of showing up. So if you definitely don't want lines like that, you can change this BREP to a mesh. I'm going to type BREP mesh. So this is going to take in a BREP and turn it into a very simple mesh. And then if we plug this in instead, then it's not going to show us any lines. And you can play around with these to see if it changes anything. Again, that's not really doing anything, but this top color will, and the bottom color will. And then we can also adjust these. And so that pretty much wraps it all up. But well done, and thank you so much for seeing it through. I hope you stick with it. There's so many amazing things you can do with Grasshopper beyond this, and it just gets easier as you go. The more you learn, the faster you learn, and the more amazing things you can do. It's so much fun.